we have integration of 2x over x plus 1 x squared plus 1. Bottom has already two factors, so we want to write this fraction as a sum of two simpler fractions, which is called partial fraction. So let me write on the here, let 2x over x plus 1 x squared plus 1 is equal to sum of x plus 1 fraction and another fraction containing x squared plus 1. This is a linear factor, degree 1, so 0 degree on the top, so constant. So degree 2, x squared plus 1 is irreducible. It's a factor but quadratic, degree 2, so we need degree 1 on the top. And generally degree 1 is used, so bx plus c. Okay, and as soon as we find a, b and c, we come back and finish this problem. In fact, now this fraction, integral of this fraction is integral of right hand side, so we can write in this way, integral of right hand side, and we have two fractions on the right. So a over, we will figure out the values of a, b and c later. A over x plus 1 dx plus bx plus c over x squared plus 1 dx. Okay, and a can be pulled outside being a constant, and 1 over x plus 1. The derivative of x plus 1 is 1. The derivative of bottom is top, so integration is natural log of bottom x plus 1 plus bx plus c. We need to separate into two fractions in this way, bx over x squared plus 1 plus c over x squared plus 1. So bx over x squared plus 1 plus c over x squared plus 1. We separate this fraction into 2, okay, and then take the integral of both. So a natural log of x plus 1 plus, now we can pull this constant b outside, and that leaves x over x squared plus 1. By the way, what is the derivative of x squared plus 1? That's 2x, but we have only x. We can always multiply by 2 and divide by 2. We can multiply and divide by constant, okay, that's allowed, but not the variable. Since we have x, we can multiply by 2 and divide by 2. Why? Then once we pull b out, 2x is the derivative of x squared plus 1. Okay, so it's b outside and 1/2, so b over 2. 2x is derivative of x squared plus 1, so antiderivative is natural log of the bottom, absolute x squared plus 1. But x squared plus 1 is always positive, quantity squared plus 1 is always positive, so we could have just written parentheses plus. Same thing here, see outside, derivative of x squared plus 1 is 2x. We could manage to, but there is no x, so we cannot divide and multiply by a variable, so the rule does not work. When c is out, this is 1 over x squared plus 1, so we will have 1 over x squared plus 1, okay, dx. It's a formula from calculus 1, you know, the derivative of tangent inverse x, inverse tangent or arctangent, is 1 over 1 plus x squared. That means antiderivative of 1 over 1 plus x squared or x squared plus 1 is tangent inverse x. So see outside, this is tangent inverse x plus we are getting constant of integration k. Okay, basically done. The calculus part is done. All we have to do now is find the values of a, b and c from this assumption. Okay, so let me leave one more line to write down the final answer, and I'm going to work on this equation to determine the values of a, b and c. Okay, I don't have room here, so let me bring this to the bottom part. This is an equation with fraction, so we want to multiply both sides by the common denominator of right side, which will be always the left side, this combined. Okay, so multiply through by the common denominator. So basically we multiply through, let me multiply at the same time, multiply by the common denominator, x plus 1 times x squared plus 1. If we multiply, then left hand side these two factors cancel, survives the top, so 2x equals, in the right hand side, first fraction times the common denominator, x plus 1 cancel, a times x squared plus 1, a x squared plus 1 plus, from the second fraction, x squared plus 1 cancel, so bx plus c x plus 1. Okay, now we want to solve this equation for a, b and c. Okay, so what I'm gonna do is distribute here, because we got product. Okay, so 2x equals, distribute this as well, ax squared plus a, just distribute, kind of is foiled, so bx x, bx squared, bx1 bx, cx c, and combine the like terms on the right side. So as ax squared and bx squared, we can combine these two, so a plus b x squared, now x squared then x, so bx plus cx, b plus cx, so x, factor x out, and constant a and c plus a plus c. Now we are saying the right hand side is equal to left hand side. Left hand side is just 2x, there is no x squared, so we can always write 0x squared plus 2x plus the constant is 0. So this implies a plus b, the coefficient of x squared a plus b must be 0, because there is no x squared, or we have 0x squared in the left side, so it must be 0. B plus c, the coefficient of x, which is b plus c, must be equal to coefficient of x on the left, that's 2. And a plus c, constant term, there is no constant term in the left, so a plus c must be 0. Okay, with this, left hand side will be equal to right hand side. Now we solve this system of linear equations for ABC. Solving, we get, let's see, so a plus b equals 0 means a is same as negative b, and here a plus c equals 0, that means a equals negative c. Okay, so we need to play with these equations to determine a, b and c. Okay, let's combine first two and try to cancel b, then we'll have a relation with a and c, and a and c here, and we'll work on third. So from plus b is b, so subtract second from the first, subtract second equation from the first, or you can always solve for a equals negative b and plug in there. Okay, or b equals negative a and plug the value of b here, it's the same thing. Okay, let's do that. A plus b equals 0, that means b equals negative a. Okay, b equals negative a, plug b equals negative a into the second equation, then we get b is negative a plus c equals 2. Okay, and from this we get c, move a over, so c equals 2 negative a plus a, so we have c in terms of a. I'm gonna plug this into the third, then we can find the value of a. C equals 2 plus a. Now from the third, a plus c equals 0, and c is, by the way, 2 plus a, equals 0. So 2a plus 2 equals 0. Subtract 2, negative 2, divide by 2. So negative 2 over 2 is 1. So a equals negative 1. Now we can find all others easily. A equals negative 1. Then b is negative a, so negative of negative 1. This is positive 1. So b is positive 1. And how about c? Let's go to third equation. A plus c equals 0. And a is negative 1. So negative 1 plus c equals 0. Move 1 over. So c equals 1. C1, a negative 1, b1. Okay, go back and write down your final answer. So a equals negative 1. So this is a negative 1 natural log of x plus 1, or just negative natural log of x plus 1. And b was found to be 1 plus 1/2, then natural log of x squared plus 1, plus c was found 1. So tangent inverse of x plus k. We can combine these two natural log terms. 1/2 can be put on the exponent here and negative 1 there. Then we'll have a sum of two natural logs, which is natural log of product. But that's not necessary. This is it. This is the final answer.